Hello, so we are going to cover the quadratic formula today. Alright, so you should be able to solve quadratic equations using the quadratic formula. Alright, so you should be able to substitute given values into the formula correctly, and then as a result solve a quadratic equation. Okay, so if I gave you a scenario, imagine I said to you, solve x squared plus 5x plus 3 is equal to 0. Okay, normally what you would do from here, from your work with quadratic equations, is to factorise that, pull apart the brackets, set them equal to 0, and then solve as normal. Okay. However, it doesn't matter how many times you do it with that equation that's on your screen just now, it doesn't factorise. Okay. If you solve a quadratic equation that can't be factorised, okay, and even if they can be factorised, all right, we can use a special formula. All right, now your formula is called the quadratic formula, funnily enough. All right, so every quadratic equation can be rearranged into the form ax squared plus bx plus c is equal to 0, okay, which you know because when you solve a quadratic equation from factorisation, you have to make it 0 first. To find the solution to that equation, you then use the quadratic formula which is in the blue box at the moment. So we've got x is equal to minus b plus or minus the square root of b squared take away 4ac all over 2a. Okay, so let's take a look at the first example. All right, so we want to solve the following quadratic equation, give your answer to 2 decimal places. So we're solving x squared plus 5x plus 3 is equal to 0. I've just said in the box there, if there is any type of rounding element, all right, more often than not, you're going to have to use that quadratic formula. Okay, so the fact that it says give your answer to 2 decimal places and it's a quadratic equation, okay, you're going to have to use the quadratic formula. All right, it won't always be 2 decimal places, could be 1, could be significant figures as well. Okay, let's take a look at this first one. You're looking at x squared plus 5x plus 3 is equal to 0. We know that any quadratic equation can be written as ax squared plus bx plus c is equal to 0. All right, so what I generally call this are your ABCs. Okay, a is going to be the coefficient before the x squared. All right, obviously there's not a number there, but there's one lot of x squared, so a has to be equal to 1. B is then the coefficient before the x, including the sign, so b is equal to 5, and c is your constant, again, including your sign, so c is equal to 3. Okay, all right, if we use the quadratic formula, we've got x is equal to minus b plus or minus the square root of b squared, take 4ac, all over 2a. And then just literally do the substitution, okay? So we've got minus b, so it's going to be minus 5, plus or minus the square root of. So we've got b squared, so we've got 5 squared, take away 4 multiplied by 1 multiplied by 3, and that's all over 2 times 1. Now, make sure more often than not you're going to get a mark for tidying that up slightly. Okay, so if we deal with what's underneath the root sign at the moment, we've got 5 squared, take away 4 times 1 times 3, which gives us 13. So we've got negative 5 plus or minus root 13, and that's all over 2. Okay, so that's your x equals 2. Now, you know that from solving quadratic equations using factorisation, all right, you know that you always come out with 2 answers. Okay, you always come out with 2 answers. Now, that looks as though it's one answer, but see if you look just in the middle of the formula, okay, you've got that plus or minus. You're going to have a version or an answer with the plus root 13, and you're going to have a version that's got the minus root 13, okay? So that's where your 2 answers are going to come from. Okay, so let's scribble down what we've got so far. So we've got x is equal to negative 5 plus or minus root 13 all over 2. All right, now, like I say, you're going to have 2 versions. So you're going to have x is equal to negative 5 plus the root 13 all over 2, or same setup as before, you've got one version, you've got a second version. We've got x is equal to negative 5 take root 13 all over 2. All right, and then essentially just work that out. So if you pop the first one into your calculator with the positive version of root 13 in there, we're going to get negative 0.6972, etc. Okay, so that's your unrounded version. And your rounded version, remember you wanted 2 decimal places, so you've got negative 0.70. Remember, it asked for 2 decimal places, make sure you get that 0 in. Right, you're going to do the same thing for the second version, which is the negative version of root 13, and you're going to divide that by 2. So we should have negative 4.3027, etc. Into 2 decimal places, that's going to be negative 4.30. And again, because it's asked for 2 decimal places, go make sure you've got that 0 in, please, folks. Okay, so for the second example, all right, I've said there, be careful when you're stating your ABCs. Okay, this is mainly because of the negative, all right, so remember, sign belongs to the term, you're looking at the sign to the left, so be careful when you're stating what each of your values are. Can you pause the video for me, please, folks, and have a go at that question, and I'll go over it in a second. Okay, so as always, you're going to want to do your ABCs on this one. Okay, so A is going to be the coefficient before x squared, which is an invisible 1 in this case. B is going to be the coefficient before x, which is negative 4. Be careful, sign belongs to the term, it's negative. And C is going to be positive 2. You then substitute that into your formula, so you've got x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay. All right, so all you need to do now is substitute into that formula. So you've got minus 4. Be careful with that. Okay, plus or minus, make use of brackets. It's negative 4 squared minus 4 times 1 times 2. And that is all over 2 times 1. Okay, now let's tidy this up a little bit. Okay, there's quite a lot of negative numbers kicking about there, so let's just be careful. Minus 4 is going to give you positive 4, plus or minus the square root of, now negative 4 squared, okay, remember when you square a negative, you're always going to get a positive number, so you're going to end up with root 8, and that's all over 2. Okay, so we've got x is equal to 4 plus or minus root 8 all over 2. We're going to have two versions, one with a positive root 8 and one with a negative root 8. So we're going to have x is equal to 4 plus root 8 all over 2, or x is equal to 4 minus root 8 all over 2. Okay, all you're doing is popping that into your calculator. So we've got 4 plus the positive version of root 8 all over 2, and we've got 3.4142, etc. You were asked for 2 decimal places, so you're looking at 3.41 on that one. Okay, you're now going to do the same for the negative version of root 8. And you end up with 0.5857, etc. Again, 2dp we're looking for, so it's going to be 0.59 to 2 decimal places. Okay. So make sure that you show all of that working. All right, so substitution, tidy it up, and then pull apart. Okay, so for this one, all right, again, I've said be careful with your ABCs. There is a negative in there, so you do need to make sure that you are careful with that. The rounding element on this then tells you that you have to be using the quadratic formula because we're looking at 2 significant figures, all right? Can I get you to pause the video and have a go at that? I think that the sig figs might be the bit that causes a bit of an issue, but try it and I'll go over it in a second. Okay, let's take a look at this one. So doing our ABCs on this one, A is going to be 2, B is going to be 3, and C is going to be negative 7. All right, so you're going to shove that into the quadratic formula. So minus B plus or minus square root of B squared take 4AC, and that's all over 2A. Okay, be careful with your substitution with the negatives again on this one. Okay, so we've got minus 3 plus or minus 3 squared take 4 times 2 times negative 7. Just be careful when you tidy that up. If you end up with a maths error somewhere when you're dealing with tidying up the underneath the root sign, okay, it might well be that you have maybe just made a wee mistake with your negative numbers, okay, and make sure that you make use of brackets as well. Okay, so once you tidy up underneath the root sign, we've got -3 plus or minus square root 65 all over 4. All you need to do now is get your two answers by pulling apart. Okay, so we've got x is equal to -3 plus or minus root 65 all over 4. If we pull apart at this point, we're going to have x is equal to -3 plus root 65 all over 4, or you're going to have the negative version. So you've got x is equal to -3 take root 65 all over 4. Go make sure you've got that x in there as well, please, folks. All right, make sure you're stating what it is that you're trying to find. All right, shove that into your calculator. Okay, so you've got -3 with the positive version. So we're doing plus root 65 all over 4. So we have 1.2655. You are looking, remember, for two significant figures. All right, two significant figures is not two decimal places. Be careful. We're looking at important digits that aren't 0. Okay, there's an important one. There's an important one. But with any type of rounding, you always look at the next one along, which is a 6. Okay, so it's going to bump the 2 up to a 3, so it's going to be 1.3 to 2 sig figs. It's okay that it's one decimal place. Okay, we're looking for significant figures here. All right, for the second one, okay, this is when we're using the negative version of root 65. Okay, and we divide that by 4. So we should end up with -2.7655, etc. Into 2 sig figs again. Okay, there's a significant figure, there's a second one. Look at the next one along with any sort of rounding, okay, and that 7 is going to bump up to an 8, so it's -2.8 in that one. Okay. Okay, another version that you might come across in the exam is manipulating the equation that you've got before using the quadratic formula. Now, you've met this when we did quadratic equations that you could factorise, okay? So it does make sense that you might come across the manipulation ones with the quadratic formula as well. So I'm just going to run through a couple of examples with you, all right? Again, just restating that you need to make sure that your equation is equal to 0 before you attempt to solve, whether that be by factorisation or by quadratic formula. Okay, so these are the two questions that I'm going to run through. Okay, so we're solving the following, and we're going to give our answers to one decimal place this time. Okay, now clearly neither of them are equal to 0, which is what we are aiming for. But we're also aiming for no fractions and no brackets as well. Okay, so first thing you're going to want to do with this one is expand the bracket. So you've got 2x squared, take 2x, plus 3x, take 21, and I'm just going to take that 10 off and make that equal to 0, all right? That is not in the format of a general quadratic equation, so make sure that you tidy it up. So you end up with 2x squared plus x, take 31 equals 0. All right, that now is in the format ax squared plus bx plus c equals 0. So do your ABCs on that one. All right, so a equals 2, b is equal to 1, an invisible one, and c is equal to -31, and use those values into your quadratic formula. So you've got x is equal to minus b plus or minus the square root of b squared take 4ac all over 2a, and substitute in. So you're going to have -1 plus or minus 1 squared minus 4 times 2 times -31. That's all over 2 times 2. Okay. All right, so we are going to tidy that up. All right, once we tidy that up, you end up with x is equal to -1 plus or minus the square root of 249 all over 4. Okay, at that point, you're going to need to pull it apart. So you get -1, let's use the positive version of the root 249 all over 4, or x is equal to -1 minus the square root of 249 all over 4. Okay, all you need to do is pop that into your calculators. So you've got -1 using the positive version first, all over 4. And we're looking at 3.694, etc. You were asked for one decimal place, so we're looking at 3.7. Okay. On the second one, all right, using the negative version now of the root 249. So we're going to have negative 4.1949, etc. Okay, 1 dp, again, we're looking at negative 4.2 to 1 decimal place. Okay, so what you're going to need to make sure is that you expand the bracket and tidy it up. Make it equal to 0 before you can use the quadratic formula. Okay, looking on this second equation, you've got 2x take 1 all over x is equal to 7 take x all over 2. Alright, so remember when you solve an equation that's got fractions in it, alright, you want to get rid of the denominator. So you're looking at the x times table, the 2 times table, the smallest denominator or the smallest station that appears in both. Okay, so if we multiply through by 2x, okay, so if you multiply this first, the left hand side by 2x, what you're going to get left with is 2 bracket 2x take 1. If you multiply the right hand side by 2x, you're going to end up with x bracket 7 take x. Okay, now same as before, expand the bracket first, so you've got 4x take 2 is equal to 7x minus x squared. Okay, I'm going to take everything to the left. The reason I'm going to do that, more personal preference than anything, it gets rid of that negative x squared. So we're going to have x squared, take the 7x, it's minus 3x, and then take 2, and that leaves you equal to 0. Do your ABCs on that. So A is equal to 1, B is equal to negative 3, and C is equal to negative 2, and substitute that into your quadratic formula. So you've got x is equal to minus b plus or minus the square root, we've got b squared minus 4ac, and it's all over 2a. When you do the substitution, again, be careful. So you've got minus 3 plus or minus 3 all squared, take 4 times 1 times negative 2, and that's all over 2 times 1. So definitely tidy that up, especially with the negatives, and then underneath the root sign as well. Okay, once you've tidied that up, you end up with x is equal to 3 plus or minus root 17 all over 2. Pull apart at that point, you're going to have x is equal to 3, you're going to have the positive version of root 17 and then over 2, or you're going to have x is equal to, we'll use the negative version, so it's going to be 3 minus root 17 all over 2. And all you need to do is shove that into your calculator. So we've got 3 plus root 17 all over 2. Remember, you're looking for 1 decimal place on this one, so we're looking at 3.561, etc., which is 3.6. On the second one, just pop that into your calculator again, except we're going to use negative root 17. So we've got 3 minus root 17 all over 2, again to 1 decimal place. We've got negative 0.5615, etc., which is negative 0.6 to 1 decimal place. Okay, so again, make sure that you get rid of any fractions, any brackets, all right, make it equal to 0 before you start doing your ABCs, before you make sure you tidy that up first. Okay. So in terms of solving quadratic equations using the quadratic formula, more often than not, it is used for equations that you can't factorise, okay? Normally, if it was personal choice, you would much rather just factorise it. It's much quicker, okay? But you can use the quadratic formula even if you can factorise it, but normally it's used for when you can. All right, so substituting your values into the formula correctly after, like I say, getting rid of brackets, getting rid of fractions, okay? Making sure that it's in the format ax squared plus bx plus c equals 0 first of all.